So, okay, for the linear equation of the two-set linear equation, so this is basically talk about the matrix and the determinant. So in general, if we have a linear equation like the ax plus the by equals e and the cx plus dy equals f. Okay, so what we can do is we set them into a linear equation like a matrix. So a and b and c and d. Okay, so here it basically the first row is the first equation. Okay, that's 1 and 2. The second row is the second equation. Okay, and the xy equals the c the e and the f. Okay, so basically the first column is the coefficients to the x. You can see it's a and c, and the second column is the coefficients to the y. You can see that's b and d, and here is the constant. That's the e and f. So to solve this equation, we can use the determinant. Okay, the determinant in the vector geometry, it means it can mean the assigned area. Okay, for example, if we have the a and b and c and d, it will be assigned area, okay, of this parallelogram. Yeah, we talk about this one later. If we talk about there are some formulas to calculate the enclosed polygon area. Okay, the area of the enclosed polygon on the 2D two-dimensional coordinates plane. But here we just define how we can solve this linear equation. Basically, we solve the d equals to the determinant of the a, b, c, d. Okay, that's this matrix. So this one has, per definition, is the main diagonal, and the opposite diagonal is a times the d. Be careful, it's minus the b times the c. So we can also define the dx. The dx means the coefficients to the y column doesn't change, okay? But the coefficients to the x is replaced by e and f. So the determinant is e times d minus the f times b. Okay, and we can also define the dy equals, it's the a and the c, it's the coefficients to the x, and the coefficients of the y has been replaced by e and f, so it becomes the af minus ce. Okay, then you can see the x equals dx over d, and the y equals dy over d. That's the solution. But here you need to know that's this one, okay? The d cannot be 0, right? Because you can see the d is on the denominator, okay? But here there is one thing very important you need to know is if d is 0, okay, means the two equation, means the equation 1 and equation 2 is the same. Basically, it's the same equation. We call the linear dependent. Okay, so these two columns are linearly dependent. So basically, it's the same thing. So that's why you cannot solve it. Okay, that's the question for this one. And now let's solve the question of this one. Okay, this is a Amy problem. So the Amy problem is normally is pretty hard, okay? And also this one, you can see, okay, here, let's see the pattern, okay? So we have the, okay, let me stop for right now, and I have limited time of my recording, so let's do a new recording for this problem.